The last day I had you, we were looking at our averages, and we had 3 different averages, the mean, the mode, and the median, and you guys need to be able to calculate these, okay? And to recap on that, we're going to now take a look at some exercises that we would have done last night, okay? So I'll break away to my iPad and we'll do them out by hand, and we'll come back to the board for a bit of instruction on what we'll be covering today, okay? So I'll leave you at that, I'll see you in a few minutes. Okay, so let's take a look at some of the homework we had for last night. I might just answer this question here and this question here, and that should cover you for kind of question 1 and question 2 if you can answer the hardest ones, okay? So the first question was to find the mean of this data set here. So to find the mean, we add them up. So it's 5 plus 12 plus 3 plus 4 plus 3 plus 6 plus 9, and we divide it by how many there are, and there's 1, 2, 3, 4, 5, 6, 7. 2, 4, 6, 7, yeah, there's 7 of them. So that's a calculator job. So into the calculator, and we get 5 plus 12 plus 3 plus 4 plus 3 plus 6 plus 9 equals all over 7, which is equal to 6. So the mean of this data set here is 6. Okay, question 1, and that was part IV. Let's now take a look at question 2, part B. So we're asked to find the mean for, or the mode, sorry, first of all, and the mode is the most common one. So the mode, let's take a look at the mode here. So we've 1, 2, so we have 2 3s, we have 3 7s, so 7 is currently the mode, we have 2 8s, so 7 is still winning, 9, no good, 5, no good, 11, no good, 12. So 7 is the mode. So the mode is a really easy one to calculate because it's just the most common one. Now, the median of this list. So we're going to list them out. We're going to go 3, 3, 7, 8, 7, 9, 8, 5, 7, 1, 1, 1, 2. And I would be tempted to jump in here and start going ticking off. But I'm not going to do that because it's the middle of a list. But the middle of this list makes no sense because this list is not in order. So I'm going to have to put this in order first of all. So the smallest one here is 3. And the biggest one is definitely 12. How many 3s we have? We have 2 3s. Then we have a 5. 11 will be up here. Then 9. Then 8. Then 8. And then the 3 7s. So our list is now in order. If I want to find the median of this list, well, I simply go ticking now. And I tick off the biggest with the smallest, the next biggest with the next smallest, the next biggest with the next smallest, next biggest with the next smallest. And I put 1 in the middle. So that guy there is the median. Question was, write 5 numbers so that the mode is 4, the mean is 6, and the median is 5. And they gave us some spaces there. They gave us 1, 2, 3, 4, 5. They gave us 5 different spaces that we can write in. So let's think about this. So there's some clues here. Mode is 4, mean is 6, and median is 5. Median is 5. That's where we're going to start, okay? So the median is 5. So that means that this one here must be a 5. Okay. Now, the mode is 4. That means that there needs to be more than one 4. Let's put 4 there and 4 there. We can't put 4 over in these boxes over here because this list is in order and that's the median there. So the 2 4s must go there. Now the mean has to be 6. So that means I have to add up 4 plus 4 plus 5 plus this box plus this box, and it has to be all over 5. And we know, because 4 has to be the median, we know that this box cannot equal this box. So I'm going to call one x, I'm going to call one y. So that's x and that's y. So we now need to choose values of x and y that will make this thing here equal to what? Equal to the mean, which is 6. So I now have one fraction equaling one fraction. So I have 4 plus 4 plus 5 plus x plus y must equal 30. So I cross multiplied. I now have 9, I now have 13. 13 plus x plus y is equal to 30. So I now have x plus y is equal to 17. 30 minus 13. X plus y is equal to 17. So I'm going to pick maybe an 8 and a 9. So I just need two numbers that will add together to give me 17. So it's 4 plus 4 plus 5 plus 8 plus 9 equals, divided by 5 equals 6. Yeah, so that will do the job nicely. There's probably a number of values that we can choose for this. So we could choose something like 6 and 10. Sorry, we could choose 7 and 10 if we wanted to. So 7 and 10 would also be valid. So we're just looking for two numbers that add together to give us 17. We put the biggest one on the right. Right, so question 17 here. The numbers 4, 8, 12, 17 and x are arranged in order of size. If the mean of the numbers is equal to the median, find x. Right. That's going to be quite a tough question here. I don't actually even know how to tackle this myself, but I suppose we'll just get jumping in. We know that mean is add them up. 4 plus 8 plus 12 plus 17 plus x all over 2, 4, 5 all over 5 equals oh, we're given a clue. We're told that they are arranged in order of size. So when we do this sum, the answer is 12, because that is the median. Ah, there we go. Okay, so that's going to be 4, 12, 24, 31, 41. So we have 41 plus x all over 5 is equal to 12. So that will now give us 41 plus x is equal to 60 when we cross multiply. And x therefore is equal to 60. Take away 41, x is equal to 19. And this part here is part 1. And this thing here is part 2. Sorry, you didn't need to know that. You just need to find x. I was reading question 19. Yeah, okay, so that's question 17 answered. Let's take a look at question 19 now. The mean of 5 numbers is 39. Two of the numbers are 103 and 35, and each of the other 3 numbers is equal to x. The total of the 5 numbers, the value of x. Well, to answer the total of the 5 numbers, to answer this question here, we're going to go back to that egg demonstration I did the other day. We're averaging, or finding the mean. When we find the mean, it's like we're giving each of the egg cartons the same number of eggs. So in this case, we're giving each of the numbers the same number. So we're giving each of the 5 numbers 39. So it's 39 times 5. And that's the same as 40 times 5, which is 200. Take away 5, which is 395, is it? Better check on the calculator. Sorry, 195. Okay, so it's now coming on past midnight. So please excuse my arithmetic. Now, the value of x, okay, so we now know that when we add 103 plus 35 plus 3x together, the answer should be 195. So we're adding all our numbers up, and they should equal 195. So 3x, therefore, is equal to 195 minus 103 minus 35. So 3x is equal to 195 minus 103 minus 35, which is equal to 57. And is 57 divided by 3? I think it is. 57 divided by 3 is equal to 19. So x is equal to 19. So very difficult questions there, question 17 and question 19, okay? They would be kind of, well beyond the standard exam questions, okay? Maybe if it was 2015 or something, they might ask a question like that, but in a kind of a standard year, they would be very difficult exam questions, okay? So don't be too worried about that level of difficulty, but they're interesting nevertheless. Okay, we have our three averages, and at this stage we know how to calculate our three averages. We know how to calculate mean, mode, and median. But we still don't know whether the statistics that we're given, if we're given someone a mean, we don't know if that's really a good statistic or not. Okay, we know when to take the mean, and we know when not to take the mean. So if there's a big outlier, we would not take the mean. But in the absence of any outliers, we kind of have a load of information around a centre, well then we would take the mean, no problem with that. But we need to communicate if it's a good mean or if it's a bad mean, or how strong, how reliable we can use that statistic, that mean. So I'm going to take a look at two different data sets, and it'll kind of show you, I suppose, a weakness with just giving someone the average. We should also give them another piece of information when we give them the average, sometimes. So we're also going to do something a little bit different now. There's a word we're going to be learning later on today, and that word will require us to put our smaller numbers at the bottom and our bigger numbers at the top. So when I'm giving you data sets, I'm going to try, and this is my first year doing this, but I learned from last year that we had problems. I'm going to put my small numbers at the bottom and my big numbers on top. So I'm going to give you an ordered data set, and the first one is going to be 1, and then I think it's 301, and let's try 601. Okay, so that's our data set there. That's our first term, our second term, our third term in our data set. That's one data set. And over on this half of the board, I'll give you another data set. Let's say if I gave you 300, and I gave you 301, and I gave you 302. 302. So that's a 3, by the way. So I'm giving you those three entries and two data sets. I'm going to ask you to find the mean. So work out the mean of those three. Work out the mean of those two data sets for me now really quickly. So what's the mean of this data set over here? And the mean of this data set over here. So pause the video now and work those out. I'll keep working, so you can join back in when you found out those two means. Okay, so the mean of this one here is going to be, add them together, that's going to give us 903, sorry. That's going to be over 3, and that's going to equal 301. So the mean of this data here is 301. The mean of this data here is 903 again, all over 3. So the mean of this data is also 301. Okay, but if the mean of that data over there is 301, and the mean of this data is 301, both of those two things are communicating as they currently stand, the same piece of information, that the mean of this data set is 301. But this claim here is a lot weaker, because if we were going to estimate that the next value in this data set would be around 301, well, I don't think we could really say that with much certainty, right? But if we were to make the same claim here, well, the mean of these 3 points here is 301, so yeah, I think the next one could be around 301, right? So the way we kind of communicate that this is a good mean or a strong mean, and this is kind of a very weak mean, would be a thing called range. So it kind of associates a quality of mean, or of any of the 3 averages, provided they are numeric. So by range, I simply mean the distance from the smallest up to the biggest. So this one over here will have a huge range. The range of this one is equal to 600. Whereas the range of this data set is only about what? 300 and, is only about, well, sorry, not 300 and something. It's much smaller, it's actually 2. So to get the range, I take the smallest from the biggest. Okay. So that's the range when we take the smallest away from the biggest to find how compact our data set is, how close all the terms are to the mean. So it's a good indication if it's a good mean or if it's not a good mean, or if it's a good average or it's not a good average, depending on its range. So the smaller the range, the better the measurement of average is. Okay. Now, so this is one way in which we can do this. So there's going to be more than one way, and all of these ways are measuring things called spread. So let's stick it up there. So these are our spreads over here. So we have our averages over here, and we're going to have our spreads over there. So we're looking at how our data is spread out. In this example here, in this data set, it's spread out over 2. In this data set here, it's spread out over 600. Okay. So that's our first measurement of spread that we've encountered, range. Very, very straightforward. It's a very basic understanding of spread, and we calculate the very simple range. Okay, but nevertheless, it is important that we do understand how to calculate the range. So that's range for us. So I'll pin this up on the board. So to calculate range, we simply take the smallest away from the biggest. So I'll clear the board and we'll take a look at the next type of spread. We're now going to talk about our next measure of spread. We're going to take a look at this data set here to kind of illustrate the point of when it's useful. I suppose before we start, we might just take a look at this data set. We kind of have a cluster of data down here around the kind of 40s and 50s. But we have one giant piece of data up here at 163. So he causes us some difficulty, because if I was to calculate the range of this guy, well, he's going to be something like, 122, is it? I think the smallest away from the biggest. So my range in that case is 122. So that's quite a big range. But realistically, because of this outlier here, and he's kind of unique, we can kind of say that if the average we got, we calculated let's say median. So if we calculate the median, our median is around here somewhere, 51.5 or something. But if we use that average, using that range wouldn't be much good to us really, because we can kind of say that the next one, the next term, if there was going to be another one added to this data set, it's probably going to be around 51.5. Okay, we can say that. So we want some method of spread, some way of measuring spread that will kind of eliminate the power of these outliers. So just like we had to eliminate it when we're finding means, or when we're finding averages, we couldn't use it. If there was an outlier in our data set, it wouldn't be advisable to use a mean. We had to use a median. We need some way of counteracting them when we're calculating spreads as well. So the way to get rid of this outlier is to take something called the interquartile range. I'm not sure if you can see these pages over here or not, but I think you can now. We'll check it out. Anyway, I'll stick it on the board. So it's called the interquartile range. So it's still a range, it's just called the interquartile range. The interquartile range. So we've worked that out now for this data set over here. I might just kind of partition those things off so they don't get interrupted here. Okay. An interquartile range, what this means is range of middle half. So there's a half of our data in the middle in here somewhere. And it's the range of that data. That's what the interquartile range is measuring. So it's the range of the middle half. So how many terms do we have in this data set? Well, we've 1, 2, 3, 4, 5, 6, 7, 8. We've 8 terms. So the middle half will contain 4 terms. So it's the range of the middle half. Yeah? So we're looking for the range of the middle 4. So we need to know, when did the middle 4 begin? When did the middle 4 end? So that's the tricky process. It's quite easy to spot here because it's a small data set. And it's kind of a nice number 8 for doing this with. But it could be something like 163 pieces of data. Or pieces of 163 data that we would have to look up. The way to do it, guys, is we know that if we find the halfway mark, first of all, and to get the halfway mark, what system do we use again? How do we find the number that's halfway? Yeah, we go ticking, right? So we take this guy off with this guy. We take this guy off with this guy. And we take this guy off with this guy. And if I tick again, I'll be left with nothing. So I don't tick again. Yeah, but instead I add these two together and divide by 2. Remember that from yesterday? So I add them together, I get 103. If I divide that by 2, I'm going to get 51.5. So our median is equal to 51.5. So I've worked out what's halfway, and halfway is in here. So I've now carved my data into a lower half and an upper half. Right. So the middle half, well, that will begin at the quarter. So at the end of the first quarter to the end of the third quarter will be where the middle half exists. So I need to know where the quarter way marks, where are the quarter points. And I know that if that's the halfway mark, well, if I half that mark, I'll get to the quarter way mark. So I have 4 terms down here. I'll use a different colour for this. I'll use blue. So I have 4 terms down here. So I can go ticking these off in order. So I can tick the top off with the bottom. I can tick them. Oh, if I tick again, I'll kill them both off. So I'm not going to do that. Instead, I'm going to add them together and divide it by 2 as normal. When I add them together, I get 86, I get 91. If I divide 91 by 2, I get 45.5, is it? .5, and that's where the first quarter ends. So I call him Q1. I then need to know where the third quarter ends. We know where it ends, but let's just go through the process that we will use in a second when we have a much bigger data set. So where does the third quarter end? Well, I tick off the top one, tick off the bottom one. Oh, if I go ticking again, I'll kill them both off. Don't want to do that. So I know that it's in here somewhere. And how do I find the number that's halfway between 53 and 56? Well, I add them together and divide by 2. So that's 109. Divided by 2 is 54.5. And that is where the third quarter ends. So I call him Q3. And now the range of the middle half will simply be this one, take away this one. So IQ range, interquartile range, is equal to 54.5 minus 45.5, which is equal to something like 9, is it? They're gone. 11. No, 9. 9. Okay, so the interquartile range, is it? I should have a calculator with me. 5 and 4 is 9. Yeah, it is 9. Okay, so that's how we work out the interquartile range. It's the range of the middle half. To get from the end of the first quarter to the end of the third quarter, i.e. the middle half, the range of the middle half is 9. Okay. I'm now going to put up a bigger data set, and we'll take a look at a kind of a more awkward example of finding the interquartile range. And then I will give you 4 data sets to work out mean, mode, median, and interquartile range of them this evening for homework. Okay. Right, so I've plucked these numbers out of my head. I've written them in ascending order, so smallest at the bottom, biggest at the top. You'll find out why in a second. I forgot to cover that before, but I have to cover it now. So we'll be learning some new words in a second. So the question is, find the interquartile range of this data set. Right, so to find the interquartile range of this data set, our first job is, well, we know that if we split the halfway mark into quarters, we'll be able to find the interquartile range. So our first job is to find the halfway mark, the median. So how do we find the median of this data set? Finding median, what do we do? Yeah, we go ticking, right? So let's get a different colour up. Do I have like blue, red? Yeah, I can go red. Okay, so let's do some ticking here. Let's tick off the biggest with the smallest, next biggest with the next 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 smallest. Oh! And if I turn in the middle, if I tick any further, I'll eliminate them both. I'm not going to do that. So I know that my median is in here somewhere. So my median is equal to 20 plus 19 all over 2, which is equal to 19 and a half, is it? I think it is. 18 and a half. And 39 divided by 2. Oh, sorry. So it's currently 11:30 at night. So my arithmetic is going to be really poor now. 39 divided by 2 is 15, and 4.5 is 19.5. Check that for me, please. Do you know, did I need to do that sum looking at it now? No, I didn't. 20 and 19, should a number that's obviously between those two is 19.5, yeah? Sorry, it's a bit late for me here, but yeah. Okay, so that's the median, 19.5. So I've now worked out the halfway mark. So I need to know where the first quarter ends, and to get that, I'm going to half the half. So I go ticking, but I'll tick these ones off. So I tick off the biggest one, with the smallest, next biggest, next smallest, next biggest, next smallest. Oh, that's a 2 in the middle. If I tick any further, I'll eliminate them both. So I now know that Q1 is in there, and Q1 is the number that's halfway between 11 and 13. So it's equal to 11 plus 13 all over 2. I won't fall into it this time. 11 plus 13 is 24 all over 2, which is 12. And that makes sense because the number that's halfway between 11 and 13 is 12, obviously. Right, so we now have Q1. Let's work out what Q3 is. The end of the third quarter. Let's take this guy off with this guy, and this guy with this guy, this guy with this guy. Oh, if I tick any further, I'll kill them both off. I'm not going to do that. So I now know that Q3 is in there, and Q3 is equal to, yeah, I can say equals. Q3 is equal to 35 plus 29 all over 2, which is equal to 33, is it? Two. So Q3 is 32, Q1 is 12. So how do I get the interquartile range? What do I do to the middle half? Interquartile range is the range of the middle half. Range, how do I calculate the range of the middle half? How do I calculate the distance from here all the way up to here? That one's 12, that one's 32. What's the difference between those two? Interquartile range? 20. So the interquartile range is 20. Now, some new words. If that's Q1 and that's Q3, what do you think I could call the median? What would be a technical symbol for median? So that's the end of the first quarter. The median is the end of which quarter? End of the second quarter. So I could technically call it Q2 if I wanted to. Okay, very rare, but you could come across Q2. You could come across the median being called Q2. Now, each of these things that I've broken my data set up into, that quarter and that quarter and that quarter and that quarter, each of those are called a quartile. So that is one. That is one. Yeah, both of those, they're both quartiles. Okay, so these 4 digits here are those 4 pieces of data. These 4 pieces of data, these 4 pieces of data, and these 4 pieces of data. Each of those is called a quartile. Yeah, it's a quarter of the entire data set. And if I asked you which one is the upper quartile, well, the upper quartile is this guy up here. Okay, So we have the upper quartile, the middle half, and the lower quartile. So upper quartile being the numbers with the quartile with the bigger numbers, the upper quartile, the bigger numbers, and the lower quartile, the smaller numbers. Yeah? Okay? So that's your new word that we need to cover there. And Q obviously stands for where the quartile ends. I always call them quarters, but they're actually quartiles, is more correct way of calling them. So that's interquartile range covered. We've also covered range. So just to kind of recap now, we might just mark up each of these things here, how we calculate them. So how do we calculate range again? Calculate the range, what do I do? Yeah, biggest minus smallest. Biggest minus smallest. So to calculate the range, I take the smallest away from the biggest. To calculate interquartile range, well, we'll take it that we know what range is. So to calculate interquartile range, it's range of middle half. So really the calculation for interquartile range is not bad at all. Because it's just a subtraction, but it's working out where the middle half is. That's kind of the hardest part to it. So there are your two new concepts today. How to calculate range, how to calculate interquartile range. I don't think there's much point in examining range, okay? If you can work out the interquartile range, you can work out a range, yeah? Because you can do subtraction. So I'm going to put up 4 data sets. I'll get you to work out the mean and the median, and the mode if it's relevant. And I'll also get you to work out the interquartile range tonight of these 4 data sets. So we have our 4 data sets here, and tonight you're going to work out the mean, the mode, and the median, and the interquartile range, and the range for each of these data sets. For some of them, the mode may not exist, okay? There may not be one particular one which is more common than any other one, so the mode may not exist for some of these data sets. But for each of these 4 data sets, see if you can work out the mean, the mode, the median, the interquartile range, and the range. I need to talk about these two over here. I've been really nice to you up until now. I've always given you data that goes from smallest to biggest, and it's kind of ordered. This one here is all jumbled up. So you're going to have to work out, in order to calculate the median and the interquartile range, you're going to have to put them in order. Okay, you don't need to put them in order to get the mean, but you will need to put them in order to get the median and the interquartile range. So that's your work for tonight. So I'll see you again on Friday. Stay safe, guys.